Welcome, guys. So today we're talking about momentum and collision. Momentum and collision. So, what is momentum? So, momentum is defined as the product of the mass and the velocity of a body or an object. So, it has to do with the product of the mass of that particular object and also the velocity of that particular object or that particular body. So it has to do with the multiplication of the mass and the velocity of that body. So having the formula to be, so we represent momentum by this P. So to be mass times velocity, where m is the mass and v is velocity. So unit of velocity from this formula we can denote that. So that's kg meter per second, because the kg is denoting the mass and meter per second denoting the velocity, and it's a vector quantity also having the same direction as the velocity. So that means the momentum will be having the same direction as that of the velocity. So from there we move to what we refer to as Newton's second law. So there's a connection between this Newton's second law, momentum form, and momentum itself. So we can see the Newton's second law but a momentum form, stating that the force acting on an object is equals to the rate of change of its momentum. So the force acting on a particular object or a particular body, so is equals to the rate of change of its momentum. So the way the momentum is changing, then the force acting on the object is equals to the rate at which. So if there is increase in the force, there will be increase in the momentum. When there is decrease in the force, there will be decrease in the momentum. So it's something similar. It's something like that. So there will be increase in the force when there is increase. There will be increase in the momentum when there is increase in the force. So having the formula, the force is equals to the P over the T. So the P denoting the momentum over the time, which is denoting the rate. So and that is equals to mass times acceleration. So where the P is what? The momentum, the T is the time taken, and the M is the mass. So why the A also is acceleration. Now there is another thing we need to know, which is referred to as the impulse. The impulse. So impulse, that's when a force acts for a short time, it produces a change in momentum called impulse. So that means when a particular force, now we know the force actually causes the momentum, causes the rate of change in the momentum. So that means when that force acts for a short time, it produces a change in momentum, and that change in momentum is referred to as impulse. So that means impulse is change in momentum. So formula, impulse is equals to the force times the time, which is also the same thing as the change in momentum. It also has the unit of Newton seconds or kilogram meter per second. So in unit similar to that of momentum. So that is impulse equals to change in momentum. Now let's check an example of this impulse. Let's check an example. I said example, catching a ball. Say catching a ball, you apply a force for some times to stop it. So you are trying to catch a ball now. So you have to apply a force for some times for the ball to stop, for you to be able to stop the ball and be able to catch that particular ball. So you applying that force is you causing a change in the momentum of that particular ball. Okay. So this leads us to what we refer to as principle of conservation of momentum. Like it's similar to that of conservation of energy. So there is also a rules that refers to as principle of conservation of momentum, stating that in an isolated system, note, no external force. In an isolated system, meaning that no external force, then the total momentum before the interaction equals to the total momentum after the interaction. This formula or this principle is where all different type of cases of momentum is going to come from. So it's very, very important actually. So it's saying that in an isolated system, meaning that no external force is acting, then the total momentum before the interaction, so before the interaction or before the collision, anything you use, so either you said interaction, either you said collision, equals to the total momentum after the interaction. So assuming, let's give an example of this kind of momentum. Maybe you hit a ball to the wall. So before you hit the ball is going with a momentum. Now when it hits the wall and comes and bounce back, there is also a change in momentum. So now the total momentum before that interaction will be equal to that momentum after interaction. So having the formula M1 U1, let's assume M1 is for the ball, U1 is for the ball. So M1 is the mass of the ball, while U1 is the velocity of the ball, initial velocity. M2 is the mass of the second body. So let's assume we hit two balls together. Why u2 is the velocity of the second body, initial velocity. Now we'll be having m1, which is now the new mass of the mass of the ball, because the mass of the ball will not change. So it will not change on this kind of note. So the mass of the ball still remaining the same, but there will be change in the velocity and the mass of the second ball and the final velocity. So meaning that this hold true for all the type of collision, either the perfect elastic collision, the inelastic collision, or the elastic collision. So it holds for all the type of collision that we'll later be talking about. So stating that total momentum before the interaction is equal to total momentum after the interaction. Okay.